Let us note what the word symmetry mean in general. Afterwards, we will discuss what is meant by molecular symmetry, what are the elements possible which are responsible for the symmetry, and possible actions on the elements means symmetry operations. So let us discuss the meaning of the term symmetry. I show you here few images. What you need to do, just ask yourself, is that image symmetric? If symmetric, why for? What is the criteria to decide the symmetry? Why for you feel that image is symmetric? Okay, let us begin. See here. Coconut leaves. Do you think this arrangement is symmetric? Generally, people think yes, it is symmetric. But what I want particularly, why for you think it is symmetric? Yes, it is a time to think about that. Let us see one more. Nature's gift. Beautiful butterfly. Is it symmetric? Yes. Many times these beautiful things we like because of symmetry only. But we never think, or generally we do not think about why for we say it is symmetry. You can find there one line passing through the body of the butterfly and that divides. Means here and there, left and right, some similarity is there. Keep this point in mind. It's a man-made arrangement, but beautiful, no? Excellently fruits are arranged. So we appreciate that, we praise that, we feel it's a good because of symmetry. What exactly symmetry is there that we need to find answer? Let us see one more. See this pair. Individually each one is symmetric, but arrangement of these two also is symmetric. Symmetric means exactly what? Let us see one more image. Is it symmetric? If so, why for? Now see one more image. Is architect in this image symmetric? What is the reason for that? See one more image. Is this construction symmetric? If so, why? Now see one more image. Our beloved tricolor. Is it symmetric? If it is, why for? For these all images which I have shown to you, what is your answer for the question? Is it symmetric? I guess your answer was yes. Each image that I had shown was symmetric. Apart from the color combination and color similarity, one thing you might have noted, arrangement of the items, arrangement of the things. And in arrangement, somewhere you were finding symmetry. Maybe aboveness and belowness, leftness and rightness, cornerness, somewhere there was regularity. So, it is a general idea about the symmetry. But exactly what the word symmetry means? I give you the answer. In the word symmetry, first three letters are there. Which are those? SYM. Actually, sim is a variant of a word sin. SYN. Meaning of sin is together. Meaning of metry is measurement. So what is the meaning of symmetry? Measurement of togetherness means symmetry. Yes, interesting, no? Symmetry is measurable thing. Togetherness is measurable thing. Arrangement of the items in various particular manners is a measurable thing. But we have not thought about such measurements till now. Means our approach was only appreciation oriented, qualitative aspect oriented. Now it is a time to understand quantitative approach to study symmetry. Means mere answer whether it is symmetric or not, that is not very important. Important is how much symmetry is present. Quantitative measurement of the symmetry. How can we do that? Let us understand it by the term molecular symmetry. What does molecular symmetry mean? Yes, it is a measurement of molecular togetherness. If we need to measure anything, or if we need to construct a thing with measurement, then we need elements, we need tools. For example, in school days we were using compass box, and in that compass box different elements or tools were there. Which were they? Ruler, compass, protractor, divider, square sets. With the help of that, many geometrical construction and measurement we were doing. Same thing. In molecule, there remains such tools or elements by which we can understand that molecule, we can measure the molecular togetherness, means we can measure the symmetry. Such tools or elements are none other than symmetry elements. Before going to the direct definition, let us find them at our own, which elements are possible. Let us take one example. Say water. Means for water molecule, which elements are possible, that we will find out. This is a water molecule. Now what we will do? We will apply one mathematical term, permutation. Means possibilities, but ordered permutation with a definite order, with a definite sequence. We want to obtain indistinguishable structures. Means if somebody sees that water molecule and close the eyes, and if I show the other structure, actually I might have changed the structure, but that person will feel as if like both molecules are same, both arrangements are same. But in true sense, you might have done suitable change in the molecule. Means those two structures are indistinguishable. How to obtain these indistinguishable structures? What are the symmetry elements, means tools possible, that we need to find out. Now what I do, I show you the various possible ordered permuted arrangements I represent in front of you. Then what we need to do, what exactly happened? Where is their togetherness? What is not changed? Who is not displaced at all? That thing we have to find out. And that thing is none other than our element, our tool by which we can describe the change, by which we can describe the symmetry. I repeat what I am saying. I'll show you various structures, ordered permuted structures of water molecule. You need to answer for the question, what is not changed, who have not changed, who still remain together. And those together spaces are none other than our elements, our tools, and who can help us to measure molecular symmetry. Now let us understand this concept of finding elements of symmetry by one simple example, by water molecule. Here I represented water molecule. One oxygen and two hydrogen atoms are there. See, how are they? It's represented in White House. Means around water molecule there are white dots. All atoms, means two hydrogens and oxygen, are smiling. They are looking towards us. Left side hydrogen I am considering as first hydrogen and right side means from our right side. Hydrogen is second hydrogen. Now, one interesting activity we need to perform. Whatever the structural arrangement is there, no, we should use our creativity to rearrange these atoms in orderly manner, and we should find a number of possibilities of arrangement and rearrangement. In mathematical language, if I have to talk, then I'll say we need to find out all possible ways of orderly permutation for the structure of water molecule. Yes, what do you think? How many possible ways will be there by which these atoms in a water molecule we can arrange or rearrange? What do you think? Yes, these are the four possible ways by which we can arrange the water molecule in order to get indistinguishable structures. Here, for the sake of simplicity, eyes and smiling that I have shown, but in true sense, hydrogen atom from all angle will be the same. Same is the case for oxygen, but different ways of arrangements are there. Can you find differences? See, first structure was as was the original structure of the water molecule. Second one means up right side. What has happened? The faces of all atoms are away from us, and atom number 2 come to left side. How can you understand the structure number 3, left bottom? Yes, as is there in the structure number 2, atoms are not pointing towards us, atoms are not facing to us, but atom number 1 is to left side. What is the last possibility? There all atoms are facing us, but atom number 2 is to left side. Each structure is different. Once we know these possibilities, now next task is how can we obtain that possible structure from the original structure? How many points in the original structure are not disturbed? They still remain united. They have not changed their position. That will give us exact idea about the symmetry element. Let us discuss one by one. It is a original structure. Now what we have to do? All possibilities of arrangements, those we have to correlate with this structure. Now let us consider first possibility. What you have to do? You have to find differences in those two structures if they are. And if differences are there or no differences are there, then how can we achieve that? Which points are not disturbed? Means which point have not changed their position. That will give us idea about a tool called as symmetry element. Now I want answer from you. What do you think? Which points are not disturbed? How can we convert the left side structure into right side structure? Is there any difference, or both structures are exactly same? Means are they identical? What do you think? Yes, both structures are identical to each other. means there is a no change at all in those two structures. Without a change, we can obtain structure number 2 from structure number 1. So, which points are not disturbed? All points are not disturbed. Means all points in White House and in water molecule are not disturbed. They are together. And as per our concept, the points which are not disturbed constitute element. So collection of all these points is our element, and that element is called as identity and represented as capital E. Now let us find the answer for the question, how can we obtain second possible structure from original structure? See, both structures are in front of you. What are you finding there? Which points may be not disturbed while obtaining structure number 2 from original structure? Yes, central line will be there. It is represented now. Those points are not disturbed. Those remain still together, though other points are disturbed. So the points which are together is a tool to obtain our possible structure number 2 from original structure. So that line is called element of symmetry, and name of that element of symmetry is axis of symmetry, and its name is C2. How it came, that we will discuss later. Now let us correlate third possible structure with original structure. What are you finding in those two structures? What do you think? Which points are not disturbed during conversion of original structure to third possible structure? What's your guess? Yes, there is a plane. Now, what kind of plane is there? That I'll show to you. See, by black color, molecular plane is represented. How is that plane? It is a lamina or plane which passes through all atoms, means through oxygen and both hydrogens. It is molecular plane, and due to the action with the help of that molecular plane, we are getting third possible structure, and that action is reflection action. The atoms which were facing to us, now because of the action, due to the existence of that element, that's a plane of symmetry, now will face away from us, so their face went to opposite direction. So this is a one kind of element present in the water molecule, due to which reflection may possible, and this element of symmetry is represented by sigma, is a notation for that. Now let us correlate fourth possible structure with original structure. Both structures are in front of you. What do you think? How can you obtain that fourth possibility from the original structure? What you need to do? Which points will be not disturbed? While considering points, you will consider the points in the molecule or from the atom and from the White House. What you need to consider to get the fourth possibility? Yes, can you guess? See, I represent the answer now. What I am going to do, I am going to highlight those points which are not changed. even though other structural arrangements have changed. And I am getting answer as this one. See here. You may be finding there is only line. No, it is not a line. It is a plane perpendicular to previous plane, perpendicular to molecular plane. It is passing through only oxygen and it is bisecting the angle between two hydrogens. It is just a mere collection of small points, no? Therefore, you are finding very small thickness for the plane. It looks like mere line. So this is a plane of symmetry present in the water molecule. But this plane is a perpendicular to previous plane. And this plane of symmetry is represented by other plane. So notation is sigma dash. So which elements we found so far for the water molecule? The first was identity. Second, axis of symmetry labeled C2. Third, molecular plane of symmetry labeled sigma. And fourth, plane of symmetry which is perpendicular to the molecular plane represented as sigma dash. Now, if we know the symmetry elements, then symmetry elements always adhere with the action. So, which possible actions are there? Which possible operations are there which we can carry about, around, through symmetry element? Total 5 elements are there. Each element we are discussing in detail. First one, identity. It is represented as capital E. And which action is possible? Do nothing or do such a thing by which originality is restored. It encompasses all points of the molecule and the White House, means surrounding of the molecule. Second element of symmetry is axis of symmetry. It is represented as Cn, where n is order of the axis and it is a collection of points in a line. So one line can represent axis of symmetry. Third element of symmetry is plane of symmetry. It is a two-dimensional entity. It covers a lamina. It cuts the molecule in two equal halves. It is represented as sigma. And which action is possible through sigma? Reflection action is possible. Fourth possible element of symmetry is center of inversion. So in molecule there remains one point which can be a reason for center of symmetry. It is represented as small I and action possible through that point, action possible through I is inversion. In detail we will discuss later. And the last element of symmetry is called improper axis of symmetry. It is a collection of, again, a line. It is not exactly line, but roughly it is considered as what the line. Why it is so we will discuss. And it is represented as Sn. N is a order for the axis. So how exactly we can understand improper axis of rotation and why that name improper came, that we will discuss in detail when I'll come to that point individually. But timing, remember, Sn is an improper axis of rotation. It causes which action? Double action. it is a combo operation. It causes rotation as well as reflection. So it is also called as rotoreflection operation. Total 5 elements are there and related actions clear to you. Now it is a time to give you the work. Let us see how many of you can complete this assignment. I am asking 3 questions. And all these 3 questions are related to one element of symmetry, primitive element of symmetry, which is that identity. What you understood from identity? Identity operation results identical structure. There is a no change with respect to original structure. Can we obtain such original structure which has no change at all by other elements of symmetry? So my first question is, how can you obtain result of identity through rotation operation, means axis of symmetry? Second question, how can you obtain result of identity, means original structure, through plane of symmetry, means by reflection? And third question, how can you obtain that original structure? By inversion operation. And your answers you are supposed to write in comment box. I am waiting for your answer. Let us discuss each type of symmetry element and operations related to that symmetry element from next lecture.